In this example, we want to verify that the vector valued function x of t is 2e to the minus t cosine 2t and e to the minus t sine 2t plus t solves this initial value problem. To verify this, all we have to do is plug everything in and see if it all works out. So in terms of notation, this here is x1 of t, and this bottom is x2 of t. So we just plug things in. What is dx1 dt? Well, this is going to be a product rule. So I have a negative 2e to the minus t cosine 2t. I differentiate the e to the minus t term. And then plus a 2e to the minus t. Derivative of cosine is negative sine. So I'm going to get a minus sign out front. And then a 2 sine of 2t. Now the other side of that equation is x1 minus 4x2. So x1 minus 4x2 is going to be x1 e to the minus t cosine of 2t minus 4x2 is minus 4 e to the minus t sine of 2t, and then minus 4 e to the minus t cosine of 2t, distributing out the minus 4. We can combine these together and see that we will end up with a negative 2 e to the minus t cosine of 2t, and then minus 4 e to the minus t sine of 2t, which does match our equation from up here. So that shows that this equation has now been verified. But we're not done, we have to show the other two parts as well. So for the second one, we have dx2 dt, which is another product. When we differentiate the e to the minus t, I'll just get a negative e to the minus t sine of 2t plus cosine of 2t. Or I can keep the e to the minus t, differentiate the other part. Derivative of sine is cosine, so 2 cosine of 2t, then minus 2 sine of 2t, which we can expand and combine some of these terms. For e to the minus t times sine of 2t, I will have a negative 1 from this term and negative 2 from this term. So I'll end up with a minus 3 e to the minus t sine of 2t. For the cosine, I have a plus 2 and a minus 1. So plus 1 e to the minus t cosine of 2t. The other side of that is 2x1 minus 3x2. Which will be 2x1, which is a 4 e to the minus t cosine of 2t, minus 3x2, so minus 3 e to the minus t sine of 2t, and then minus 3 e to the minus t cosine of 2t. Again, simplifying out, we can see that we will have 4 minus 3 of the cosine terms and just the minus 3 on the sine term. So again, these two are equal. Which is then verified the second of our equations here. And lastly, check the initial condition. We can just plug in 0 up above. See that x of 0 is going to be 2. E to the 0 is 1. Cosine of 0 is 1. And the bottom was e to the minus 0, which is 1. And then sine of 0 plus cosine of 0 is another 1. Means this is the vector 2, 1, which is what I wanted to show. So we have also verified that condition. Since all three are true, we know that this vector valued function then solves this system of differential equations.